Welcome everybody in a new video. In this video we'll see how the voltage partitioner works and how the current partitioner works. Before I begin, I would like to tell you that if you like my videos, you could consider the idea to give me a like or subscribe to my channel. It's just a little effort for you, but it will be very helpful for me. Okay, let's begin. Well, what is the voltage partitioner? As we have seen in the last videos, the voltage, if you have a simple circuit like this, let's make it this example. If you have a simple circuit, one generator and 3 resistors, well, the voltage of this generator will distribute on each resistor's component. So let's imagine I have 30 volts here, and then I have 3 resistors, R1, R2, and R3. Well, okay, as we have seen in the last videos, all these 30 volts will distribute here, here, and here. So this is an important concept. No one of these volts will kind of remain, or all these volts will distribute here, 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 and here. Okay, but how they will distribute? Well, they will distribute in if these 3 resistors are equal, this voltage will distribute in an equal way, like 10 volt here, 10 volt here, and 10 volt here, if they are all equal. But imagine they aren't. If they aren't equal, let's imagine they are. R1 is like 10 ohm, R2 is 40 ohm, and R3 is 20 ohm. Okay, so imagine these are the values. The first thing I have to do here is to calculate a total resistance. And the total resistance is, well, this is a series configuration, so the total resistance is just R1 plus R2 plus R3, okay? So I just add this to this to this, okay? And the result is 10, 50, 70, okay? This is the total resistance in this case. And then what I do, I have to calculate the current, the value of the current. This is the current. It flows in this direction, conventionally, okay? Still conventionally, because we know that the conventional direction of current is not the real direction of electrons. But okay, conventionally it flows in this way, okay? How much is it? Well, the current is 30 volt, the voltage of the generator divided for the total resistance. So I just have to divide the voltage of the generator for the total resistance. And the result is, let's just see, the result is 0.42 ampere. Okay, this is the current. So let's see how it will distribute, how the voltage will distribute here. To see how the voltage will distribute in these circuits, I just have to do this. I have to multiply the current for each of the for each of these for each one of these resistors. Okay, let's do it. If I multiply the current for R1, I will obtain VR1. If I multiply this current for R2, I will obtain VR2. And if I multiply the current for R3, I will obtain, guess what, VR3. And later, when I have obtained all the 3 voltage drops, this one, this one, and this one, if I add them, if I make this VR1 plus VR2 plus VR3, I should obtain this amount of voltage, because all these 30 volts will distribute here, here, and here, okay? And remember, the bigger is the resistors and much voltage it takes, much voltage drops on it, remember this. The smaller is the resistors and less volts it will take, less volts it will drops on it, okay? Remember this. So I don't think we need to make the calculus here. I don't think we need to calculate here. This video is not about calculate the exact amount of current voltage, okay? It is just made to let you understand how does it works. This is VR3, this is VR2, and this is VR1. So this is how voltage drops and a voltage partitioner works, okay? Now, let's imagine I have a parallel here. Let's imagine the same circuits, but here I have another resistor in parallel. Maybe this circuits, let's draw it. Let's imagine I have a circuit made like this, okay. R1, R2, R3, and another one, R4. R1, R2, R3, and still 30 volts here. Okay, let's imagine I have these circuits now. What I should do in this case? Well, the voltage drop or the voltage partitioner, it still works in the same way. Okay, so what I have to do now, imagine, let's give them some values to the resistors. Okay, let's imagine R1 is 10 ohm, R2 is 40 ohm, R3 is 20 ohm, and R4 is I don't know, 40 ohm. Okay, so imagine they have these values. So now what should I do? I still have to calculate the total resistance here. So the total resistance of these circuits is, well, at first I make this parallel, and the first thing I do is R2 parallel R4, and the result will be, you know, the parallel is R2 multiplied for R4 divided R2 multiplied for R4 divided for R2 plus R4. I make this calculus here, and the result is, let's do it, 20, 40. The result is 13. Okay, 13 ohms. Okay, so this is the parallel here. We'll call the resistance RP, which is resistance in parallel, the parallel equivalent, okay? And I could redraw these circuits in this way. In place of these two resistors in parallel, I can just put one resistor, which is the equivalent, okay? The parallel equivalent of these two resistors. I can draw the circuit in this way, in this other way. R1, RP, and R3. Okay, R1, RP, and R3. I can redraw the circuit in this way, and now I can calculate the total resistance, which is, now I have a series configuration, so I just make R1 plus RP plus R3. Okay, and this will be the total resistance, okay, of these circuits. And when I have the total resistance, I just have to make 30 volts divided for the total resistance, and I will obtain the current, the I. I will obtain this, the current which flows in this circuit, okay. And when I have obtained the current, I just have to do I for R1 multiplied for R1. I will still obtain the R1, and then I have to make I for RP. I'll obtain the VRP, the voltage drop on the parallel resistors, and then I have to make I for R3, and I will obtain VR3. Well, we have to concentrate on this because we already know how these two works. Well, if I add VR1 plus VRP plus VR3, I will still obtain 30 volts, yes. This is VRP and VR1. Okay, but let's concentrate now on, because if I add this voltage drop and this voltage drop and this voltage drop, I will obtain this value. still we are in the same situation as before, but now let's concentrate on this, okay, on this one. What happens here? I have a voltage drop here on the parallel equivalent, and well, what happens here, and this is a very important concept, okay, I have this voltage drop on the parallel equivalent of these two resistors in parallel. So I know the total voltage drop on the parallel, but how much is the voltage drop here and here? How much is it? Because I know the voltage drop on the total parallel. How much is the voltage drop here on R2 and the voltage drop on R4? How much is it? Well, when I know the total voltage drop on a parallel on all of this, when I know the total voltage drop on all the parallel basically, well, this value I have encountered, this value I calculated, this one, keeps staying the same. It does not divide into smaller part. Okay, remember this, the voltage drop, the total voltage drop on a parallel does not divide into smaller parts. No. The total voltage drop on a parallel keeps staying the same on each branch of the parallel. So this total voltage drop here, I calculated, it keeps staying the same value. Let's imagine it is 5 volts, let's imagine. It keeps staying the same here and the same here. Okay, so VRP is equal to VR2 and is equal to VR4. Okay, remember this. This is very important to understand and to keep in mind. So remember this. The total voltage drop here is equivalent, is equal to the voltage drop here and here. Okay. So now we have talked about voltage partitioner. Let's talk about current partitioner now. Because current in a circuit, we know that if I have a series configuration, well, we know that R1, R2, R3, I just have to add this, and this, R1 plus R2 plus R3, then I divide the total voltage for the total resistance, and then I will obtain the value of the current, you know. Total voltage divided for total resistance, I obtain the value of the current. But what if I have a parallel here? What happens if I have a parallel here? Well, if I have a parallel here, what will happen is that the current, there will be a total current. I calculate a total resistance, this parallel, then this one plus this one plus this one. I will obtain a total resistance, and then I will make total voltage divided for total resistance, and I will obtain a total current, which is this. But this total current here, once it arrives here, it will divide into two smaller parts. Let's call them I2, because there is R2 here. So this one, with this current, we'll call them I2, and this other current, we'll call them I4. Okay, so the current behaves in an opposite way in comparison to the voltage. We have seen that the voltage drops on the parallel does not divide itself into smaller parts. It keeps staying the same here and there. But the current, for the current, it is not the case. The total current arrives here, and then it divides into two smaller parts. Okay, and then here it will reunite again, and here I'll have again the total current here. But how can I find this current, the current that flows here and the current that flows here? How can I find these two currents? Well, I just have to, well, I just need the voltage drop on the parallel. Okay, I need the VRP. And once I know the VRP, I can know the value of these two currents if I know the value of the resistors. Okay, let's imagine I know the value of R2 and the value of R4. Well, if I have VRP, it is very easy to find these two currents. What will happen here is that I will make, so VRP is equal to VR2 and VR4, as we have already seen here. Okay, so now I will just make VR2 divided for R2, and I will obtain I2, this smaller current. Then I will do VR4, which is still the same. This one is the same. This one and this one, they are the same. Okay. VR4 divided for R4, and I will obtain I4. Well, in this way I obtain the two smaller currents, and if I do this I2 plus I4, I will still obtain the total current, the value of the total current. Okay, so this is how the current divides. It doesn't matter if I have in this case there are two branches, one and the other one. It doesn't matter if I have, let's say, a parallel made of 3, 4, 5, 10 branches. It doesn't matter. The total current will divide. I still have to calculate the total parallel, then the voltage drop, the total voltage drop on the parallel, and that value keeps staying the same on each branches. It doesn't matter how much branches I have. It can be, I can have 10 branches. It doesn't matter. I have still the same VRP on each branches of the parallel. Okay, and then I will make this calculus here. I will divide the VRP for each resistors on its branches, and I will obtain the current in each branches. Okay, this is what I have to do to calculate each smaller currents. Okay, if I have, let's imagine 10 branches here, this total current will divide into 10 smaller parts, and then they will unite again here. Okay, obviously the more branches I have in a parallel, and the smaller the currents will be, because the total current have to divide into many parts, so these many parts will be much smaller. If I have only two branches, okay, it will divide into two parts. Okay, if these two resistors are equal, if they have the same values, this total current will divide into two equal parts. Okay, if these two resistors are not equal, if there is one is bigger and the other one is smaller, well, the current flows much. I will have much current. I will have more current in the smaller resistors, okay, and less current in the bigger resistors. Okay, so much current in the smaller resistors and less current in the bigger resistor. So remember this. This works exactly the opposite as voltage. Okay, I think the correct way to say it works in the opposite ways as voltage. Okay, then voltage, I don't know, but I hope you understood what I'm saying. Okay, so I have a parallel, I have a total current here. How this current will divide? Well, the smaller resistors, they take more current. Okay, the bigger resistors they take less current. Remember this. This is the principle for the current partitioner. While for the voltage partitioner, it works in the opposite way. In the voltage partitioner, the bigger resistors take more voltage. Okay, and the smaller resistors take less voltage. Okay, this is how the voltage partitioner works. As we have seen, the voltage partitioner and the current partitioner, they works in two opposite ways. Okay, everything seems kinda opposite. Okay, I hope everything is clear. And for the last time, okay, here we have a voltage partitioner, I have a total current, and this total voltage, all of them will distribute on the resistors, and the bigger resistors will take more voltage, the smaller resistors will take less voltage. Okay, For the current partitioner here, I have a total current here. This total current will divide into smaller parts. Here we have only 2 branches, but we can have 3, 4, 5, 6, 10 branches and so on. This total current will divide into smaller currents, okay? So it is the contrary of the total voltage drop on a parallel. The total voltage drop on a parallel keeps staying, that values of voltage drops keep staying the same in each branches, okay? The same here and the same here for the voltage drop. The current is working the opposite way. I have a total current here. This total current will divide into smaller parts. I have 2 branches here, but I can have 3, 4, 5, 6, okay? This total current will still divide into smaller parts, into smaller currents, and the smaller currents will reunite again here, and I will have a total current again. How the current divides? Well, in the branches with smaller resistors, I will have more current. In the branches with bigger resistors, I will have less current, okay? And that's all for the current partitioner, the voltage partitioner and current partitioner, okay? I hope you have understood everything I said. I know my English is not perfect, as always, but I hope it is clear enough to understand this concept. This is my goal, my objective, to make you understand this concept, okay? So I hope it is clear enough. If you have other questions, you can write them in the comment. Don't worry, I can read English. I can understand English actually pretty good. It's just when I talk it is a bit, you know. But if you have any questions, write them in the comment and I will answer you. I will do everything possible to answer you. Okay, so that's all, and I hope you liked the video and see you in the next one.